In this video, we're going to talk about the log rule for integration. Let's talk about the basic rule first, which is 1 over x dx is equal to ln of the absolute value of x plus c. That's going to be important to have absolute value bars around that because of the domain of a log, that it has to be non-negative for the argument of the log. Similarly, we generalize that. 1 over u du is going to be ln of the absolute value of u plus c. The only time that we get to not use absolute value bars around x or u is when we know that they have to be positive because of something else in the problem. So let's go ahead and get started here with number 13. 4x cubed over x to the 4th dx. I can simplify and make that 4 over x dx. Take the constant out front. It's 4 integral of 1 over x dx is 4 times ln of the absolute value of x plus c. Let's look now at number 15. Which is 5 over 5x plus 2 dx. I'm going to make my u my denominator of 5x plus 2. My du dx will be 5. Du will be 5 dx, which is what I have right here in my numerator. So this is du over u. It's ln of the absolute value of u plus c. It's going to be ln of the absolute value of 5x plus 2 plus c. Let's look at number 17 now. 17 is integral of 1 over 3 minus 2x dx. U is 3 minus 2x. Du dx is a negative 2. So du is a negative 2 dx. Going to multiply by negative 2 in the top, negative 1/2 on the outside. Gives me negative 1/2 integral of du over u. Negative 1/2 ln of the absolute value of u plus c. Negative 1/2 ln of the absolute value of 3 minus 2x plus c. 19, integral of 2 over 3x plus 5 dx. So that 2 is not helpful to me. Make u equal to 3x plus 5. Du dx is 3. Du is 3 dx. Need to multiply by 3 in the top and divide by 3 on the outside. Gives me 2/3 integral of du over u is 2/3 ln of the absolute value of u plus c is 2/3 ln of the absolute value of 3x plus 5 plus c. Moving on to number 21. Integral of x over x squared plus 1 dx. U is going to be x squared plus 1. Du dx will be 2x, and du will be 2x dx. Gives me 2 as my multiplier, 1/2 is my multiplier on the outside. 1/2 integral of du over u is 1/2 ln of the absolute value of u plus c. 1/2 ln of the absolute value of x squared plus 1 plus c. This will be one of those situations where x squared plus 1 has to be positive. because the minimum for x squared is 0. 0 plus 1 has to be a positive number. So I don't need absolute value bars because that has to be a positive number to start off with. All right, let's look at our next problem, number 23. Integral of x squared over x cubed plus 1 dx. U is x cubed plus 1, since that's the denominator. Du dx is 3x squared. Du is 3x squared dx. 3 1/3 makes this 1/3 du over u is 1/3 ln of the absolute value of u plus c. 1/3 ln of the absolute value of x cubed plus 1 plus c. X cubed plus 1 can be either positive or negative. So I have to leave those absolute value bars there. It's not like x squared plus 1, or when I square something, I have to get a non-negative value. So let's go ahead and look at number 25 now. We have integral of x plus 3 over x squared plus 6x plus 7 dx. So let's try to make u x squared plus 6x plus 7. Du dx will be 2x plus 6. So du dx is 2 times x plus 3. I want x plus 3 dx to show up, so that's 1/2 of du is x plus 3 dx. This is 1/2 of du, and this is u, so 1/2 integral of du over u. So 1/2 ln of the absolute value of u plus c, 1/2 ln of, and this can be negative, so we need to have these absolute value bars. Now for number 27. 27 is a little tricky. So need to write this as ln of x to the negative first times 1 over x dx. My u is ln of x. My du is going to be, du dx is 1 over x dx. So this turns into u to the negative first du, or that's 1 over u du, or du over u, however you want to write that, it's the same thing. So that's going to be equal to ln of the absolute value of u plus c. That's going to be ln of the absolute value of ln of x plus c. Ln of x can take on negative values, so it needs to be in absolute value bars. Let's look at number 29. E to the negative x over 1 minus e to the negative x dx. Let's try to make u my denominator. Let's see what happens. Du dx will be a -1 times a -1 is a +1 e to the negative x. Du is e to the negative x dx. So that looks like du over u. It's going to be ln of the absolute value of u plus c, or ln of the absolute value of 1 minus e to the negative x plus c. See, e to the negative x, that can become a really big number that is bigger than 1. So that can be a negative expression. So I need the absolute value bars around that. All right, that's it for this video. And we'll come back next time to talk about some applications of exponential and logarithmic integration. So I'll see you for the next video.